Hello and welcome. Today we'll be looking at the recurrent neural networks, that is abbreviated as RNNs. I remember for neural networks, there are usually two types, that is the feed-forward neural networks, the convolutional neural networks, and the recurrent neural networks. But today we'll be looking at the recurrent neural networks. So what are these recurrent neural networks? You see that recurrent neural networks are a type of artificial neural network designed for sequential data processing and tasks. So this one deals with the data processing tasks, that's very sequential. It's a deep learning model that is trained to predict, to process and convert a sequential data input into a specific sequential data output. So you just input a sequential data and it outputs a specific sequential data. So everything in there is processed sequentially, that is one step at a time. And you see that unlike traditional feed-forward neural networks, the current neural networks have connections that form a directed cycle, allowing them to maintain a hidden state that captures information about previous inputs into the sequence. So you find that for the feed-forward networks, just as to look at it, it doesn't have cycles. Information moves from one, that is in one direction, that is from input to output. But you find that for the recurrent neural networks, it forms a directed cycle, yeah, which allows it to maintain a hidden state and also remember some previous inputs, that is a key feature that makes it be able to remember information and very useful now in language. That's like language processing. Yeah. So we look at the architecture of the recurrent neural network. And we see that you usually have an input layer, several hidden layers, output layer, and also a loss layer. That is called entropy. And we say that the input layer receives the information to the process. That is where now you have your data and the input data or the sequence of the input data. You take it here. The output layer provides the results, where you find the results. And much of the tasks are done in the hidden layers. In the hidden layer, that is where data processing takes place, analysis and prediction takes place in the hidden. Yeah. The recurrent neural networks works by passing the sequential data that they receive to the hidden layers one step at a time. So as you put your data on the hidden input layer, yeah, and it works by passing the sequential data they receive to the hidden layers. It goes in like that, and at the end of it comes to output. However, we also have a self-loop or recurrent workflow. The hidden layer can remember and use previous input for future predictions in a short-term memory component. So it has some short-term memory to even remember some previous inputs, which it can combine. It uses the current input and the stored memory to predict the next sequence. So it can remember and be able to use that memory or the sequence that was stored or the inputs to be able to predict the next sequence. Yeah, that is now where it's very useful in language. So like that's like generating text, and because it can generate some pattern of text. Yeah, so usually be able to, because of that feature of short-term memory, is able to predict the next sequence. And there are several types of recurrent neural networks. That is the real type of them, one to many. And this type of one to many, it generates one input to several inputs. So you have one input, you want to have several outputs. So one to many. It enables linguistic applications like image captioning by generating a sentence from a single keyword. So it's not that you input just a keyword and it will be able to generate a sentence. We look at the applications, for instance, ChatGPT. You can just input a single keyword and get a sentence or even a paragraph. So that is one to many. Many to many, you have multiple inputs, multiple outputs. For example, you can create a language translator with a recurrent neural network, which analyzes a sentence and correctly structures the words in a different language. So you find that you input a sentence and you get out a sentence, but now you get it into a different language. Okay. Many to one, you have several inputs mapped to a single output. This happens mostly in the application like sentiment analysis, where the model predicts customer sentiment like positive, negative, neutral from input testimonials. So when testimonials from customers, yeah, they are made by the will be converged to one output, either positive, negative, or neutral. So that is many to one. So that those are the different which have its application. Yeah. There are some excel better in some tasks, certain tasks than others. Strength and weaknesses of the recurrent neural networks. The strength is that it is excellent in time series prediction because of the teacher to remember each and every piece of information through time, including previous inputs. So this feature of remembering that short-term memory is very useful in time series prediction. Recurrent neural networks can be used with convolutional layers, can be used in the convolutional layers to extend the effective cell neighborhood. So remember the convolutional neural networks. In those convolutional layers, you can apply these recurrent neural networks. This feature of remembering, it can be able to extend the effective pixel neighborhood. Weakness. There are some weaknesses. One of the weaknesses is that it can wrongly predict the output in the initial training. Therefore, you need several iterations to adjust the model's parameters to reduce the error rate. So you need to train it much of the times to be perfect or to reduce the errors. It also processes data sequentially, as you have seen, that is moved sequentially from one net to another. This one will limit its ability to process a random number of texts efficiently. Yeah. So this sequential moving will limit when you have a large amount of data. Take more time, which is not so sufficient. Okay. So that's the strengths and weaknesses of the current neural networks. Applications of the current, there are several applications that we have seen like natural language processing, speech recognition and incidences, machine translation, image recognition, time series analysis and forecasting, language generation and dialogue systems. Remember this feature of remembering is when you remember the previous input used with the current input to be able to predict the next. And that is now I was able to be able to generate like text. Yeah. I've just stated the, the applications, but you need to add more about them. And, you can use the books in the library or search on the internet. Although I've provided a link to it, you can visit and be able to look at each of the application and even more applications. How does it happen? Like in the image recognition, in the speech recognition, how do the current neural networks play part in those? So take your time and go through the link first and see the applications that are there, but you are not limited. I mean the internet, you get more applications and be able to understand how the current neural networks are being used in the real world applications. So, yeah. So that is it for the current neural networks. Till next time.